Welcome to the second part of our journey into the basics of sampling theory. Today, we'll explore sample statistics, sampling distributions, and the concept of standard error. Sample statistics: any quantity obtained from a sample for the purpose of estimating a population parameter, population mean, mode, percentile, standard deviation, variance, proportion, is called a sample statistic or briefly a statistic. Examples of sample statistics are sample mean, that is average of sample values; sample variance, that is spread of sample values; sample standard deviation, that is square root of variance; sample proportion, P, that is fraction of sample elements with a certain property. A sampling distribution is the probability distribution of a sample statistic, like sample mean, sample proportion, etc., calculated from all possible random samples of the same size taken from a population. In other words, if we keep taking many samples of size n, compute a statistic, say, x bar, for each, and then plot those values, the resulting distribution is the sampling distribution of that statistic. Example 1. Suppose the population mean height mu equals 160 centimeters, standard deviation equals 10 centimeters. Take random samples of size n equals 25. Compute the sample mean, x bar, for each sample. Plot all those means. That graph is the sampling distribution of the sample mean. Note, the sampling distribution helps us understand the variability of sample statistics. They form the basis of statistical inferences. Sampling distribution of mean: suppose a population is described by a random variable x with mean mu and variance sigma square. Let us take a sample of size n, x1, x2, xn, where each xi is a random variable drawn independently from the population. Since each xi has the same distribution as the population, therefore, for each I, expectation of xi equals mu and variance of xi is equal to sigma square. The sample mean is defined as following: since each xi is a random variable, x bar is also a random variable, and the probability distribution of x bar is called the sampling distribution of the mean. Check the following calculation. Clearly, expectation of x bar is equal to the population mean and variance of x bar is equal to variance of population divided by n. Further, if the population is normal, then x bar follows a normal distribution with mean mu and variance equal to sigma square divided by n. If population is not normal, then also for large n, and by central limit theorem x bar follows normal distribution. Standard error: for a sampling distribution, we can compute mean, variance, standard deviation, moments, etc. The standard deviation of sampling distribution is referred as the standard error. The standard error, say, is a measure of how much a sample statistic, like the sample mean, sample proportion, etc., is expected to vary from the true population parameter. Less is better. Standard error of x bar is given by the following formula. Through examples, we see how sample size affects the mean and standard deviation of a sampling distribution. Larger samples tend to provide more accurate estimates with smaller standard errors.